Bismillahirrahmanirrahim. Assalamu alaikum. This is my first ever video about teaching, and I'll be teaching integrals, also known as antiderivatives. This is gonna be a tutorial about the basics of integrals and will be helpful for absolute beginners. And after watching this video, I'm sure students will be able to solve both the indefinite as well as definite integrals for simple functions. So a function g of x is called an antiderivative of f of x if the derivative of f of x is g of x. Let's consider this example. All the three things that we have, that is 1 by 3x cubed, 1 by 3x cubed plus 10, and 1 by 3x cubed minus 6. They are all the antiderivatives of the function x squared. Right? So we can say if we have a function f of x, then g of x, either this one or this one or this one, that could be the antiderivatives of the function f of x. Okay, so there was a mistake. This should be g of x and this should be f of x, right? If g of x is the antiderivative of f of x, then of course f of x should be the derivative of g of x. So let's get back to where we left off. We said g of x is the antiderivative of f of x. So the derivative of g of x should be f of x. Let's derivate these and see if we get the result f of x or not. If that is true, then these are obviously the antiderivative of f of x, right? So let's take the first instance, which says g of x equals 1/3 of x cubed. Derivating it, we get, let's say, e prime of x. The constant is written as such, and then the power is written as a coefficient, and the variable is written with its power reduced to 1. So 3 and 3 will cancel out and we are left with x, and 3 minus 1 gives us x squared, which is of course our f of x, right? Similarly, the other one, where we say g of x equals 1 by 3 x cubed plus 10. Derivating it is gonna give us 1 by 3 times 3 into x raised to the power 3 minus 1 plus derivative of 10 is 0. Any constant number being derivated is 0. So this is going to give us x squared again, which is of course our function f of x. This symbol is known as integral sign, and the statement that if there is a function, let's say f of x dx, and if there are no limits, no upper and lower limits, then its integral or its solution is going to give us g of x plus c. Why do we write this plus c? As we saw in the previous examples, that we got the same answer for three different things, like 1 by 3rd of x cubed, 1 by 3rd of x cubed plus 10, and 1 by 3rd of x cubed minus 6. They all gave us the same answer, x squared. So we don't know if this antiderivative came from a function which was just a variable, or it had an added constant term with it, right? Therefore we write a c there. Those integrals which do not have limits with them are known as indefinite integrals, and you will have to write the plus c after every solution. Whatever you get, you always write c. You don't know the value of c, but you just write it. And if you have an integral, let's suppose f of x, and it has limits from minus infinity to 0 or anything from a to b, let's say a to b, then these type of integrals are known as definite integrals, because their limits, their boundaries have been defined, that they range from this limit till this. And when you write its answer, its solution, like g of x, you just write g of x. The constant will come on its own when you are solving it, and there is no need to write plus c here. Right? Now we will perform a few examples to understand how to solve integrals. Basically, because integrals are known as the antiderivatives, so they are opposite to that of derivatives. Whatever you do in derivations is quite opposite in integrals. Let me tell you about the steps that we do. In derivatives, the first thing you do is that you write the coefficient, write the power as coefficient. And the second step is that you subtract 1 from the power or the exponent. So our steps for integration are opposite to those of derivation. The first thing that we do is we add 1 to the exponent or the power. Where we did what we did in the derivation, we subtracted 1 from the exponent, and that was our second step. Here, what we do when we add 1 to the exponent, whatever comes in the exponent, we write it in the denominator of the solution. Whereas in derivatives, we wrote the coefficient, the power, as a coefficient, that is, we multiplied it with the solution. Now, in order to understand derivation, we'll perform an example. We'll perform some problems to understand it properly. Let's take, for example, integral of x. How are we gonna do this? The first thing that we're gonna do is to write it as such, and its power is 1. We will add 1 to it and divide it by that. So 1 plus 1 is 2. So what we get? We get x squared divided by 2, and because this is an indefinite integral, therefore we will write c, and this is our answer. Let's take another example as integral of under the root x, square root of x. So we do the same thing. Let's write it as such. The power of x is 1 by 2 here. So carrying out the same approach, that is writing out the variable, the function, and adding 1 to the exponent and dividing it by the same 1 by 2 plus 1. This is gonna give me x raised to the power half plus 1 give me 1.5. I can write it as 3 by 2. Same goes here, 3 by 2. I can write it as 2 by 3 times x power 3 by 2 plus c. That is supposed to be my answer. Let's take another example and finish it with that one. So the problem is to find the integral of x power 4 plus 5x cubed minus 6x squared plus 9 times d of x. So the first thing is that you can write it separately. You can write the integrals separately for each terms. So I can write it as x power 4 dx plus 5x cubed dx minus 6x squared dx and plus 9 dx. Alright, solving it each. This is x power 4, so I'll be writing it x is to the power 4 plus 1 divided by 4 plus 1 plus 5 is a constant, I'll write it as such, x raised to the power 3 plus 1 divided by 3 plus 1 minus 6 is a constant or coefficient, I'll write it as such, x raised to the power 2 plus 1 divided by 2 plus 1 and plus 9 is a coefficient or constant, I'll write it as such. And with x I'll be writing, now here you can't see anything like x here, so what is it actually? The thing is that there was an x there, but its exponent was 0, so it will be 0 plus 1 divided by 0 plus 1, and you know that anything raised to the power 0 is equal to 1. So this is x raised to the power 4 plus 1, 5 divided by 5 plus 5 times x raised to the power 4 divided by 4 minus 6x cubed divided by 3 plus 9x divided by 1, which is again, and the last term will be c. We'll be writing plus c because this is an indefinite integral. In simple words, or simplifying, we can write it as 1 over 5 times x power 5 plus 5 by 4 times x power 4 minus, I'll cancel out and I'll be left with 2x cubed plus 9x plus c, and that is going to be my answer. And now one last example on definite integrals to make you understand how to solve definite integrals. This is almost the same as the indefinite ones, just one step is necessary, that is the insertion of the limits into the solution, right? So let's say I have an integral with limits 1 till 3, and the integrand is 6x plus 5 dx, right? So just like we did earlier, I'll be writing it separately for both the parts, 6x and 1 to 3 5 times dx, right? This is gonna give me 6 is a coefficient or the constant, I'll be writing it as such, and with x the power here is 1, so it will be 1 plus 1 divided by 1 plus 1, and here I'm no more gonna write c, so I'll be writing the limits, which is 1 till 3 plus, again 5 is a constant, and because there was nothing, so if there is nothing, if you don't see any variable there, that means that there the variable had power 0, because anything raised to the power 0 is equal to 1, and anything multiplied by 1 is the same thing again. So if you multiply 5 by 1, you get the 5, the same thing again, right? So 5 and x raised to the power 0 plus 1 divided by 0 plus 1, and the limits 1 till 3. No need to write c anymore. 6 x power 1 plus 1 is going to give me 2 divided by 2 with limits 1 till 3 plus 5 times x divided by 1, limits 1 till 3. 2 ones, 2 3s are 6, so this is 3 x squared basically with limits 1 till 3 plus 5x limits 1 till 3. How do you put the limits? Now putting the limits is, you write 3, and wherever you have the function the x, you are going to replace it with the limits, first with the upper limit and then with the lower limit. So I'll be replacing x with 3 and square will be written as such. Then I'll be inserting a negative sign and writing the same equation again, the same function again, and instead of x I'll be writing what? I'll be writing 1 and the square, right? Plus here next function 5, and instead of x I'll be writing 3 then minus, like same function again, 5, and instead of x I'll be writing 1, the lower limit. So the rest is easy. 3 times 3 square is 9, and 9 times 3 is 27, minus square root of 1 is 1, and 3 times 1 is 3, plus 5 times 3 is 15, and 5 times 1 is 5. So this is gonna give me 27 plus 15 is like 42. 42 minus 8 is 34, I guess. So this has given me the answer. So 34 is our answer. And if you found this video helpful, kindly give it a thumbs up, share it with your friends, and subscribe to my channel. Thank you so much.